The sky itself had not turned green yet, but the atmosphere over the plains had already been loading with exactly the kind of instability meteorologists watch for, starting the moment the Storm Prediction Center issued back-to-back moderate risk outlooks for a 4-day stretch beginning this week across a corridor stretching from central Texas up through Kansas and into Missouri. And that first outlook was just the opening scene. Over the following 72 hours, forecast models converged with unusual agreement on a setup combining 3 separate ingredients meteorologists rarely see line up this cleanly at the same time, across this wide a stretch of the country, this late in the season. By the time we're done here, you'll understand exactly what the Storm Prediction Center has actually forecast, and why some of what's spreading about this event online goes well beyond what any forecaster has said. Today, we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever personally experienced a tornado warning or seen a tornado firsthand? Tell me where you were and what it felt like. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Now, let us get into it. Let's start with what the Storm Prediction Center, the federal agency responsible for every severe weather outlook issued in the United States, actually forecasts. Because that is the first place online claims tend to drift away from the source. SPC issues a 5-tier categorical risk scale for severe weather, running from marginal, the lowest tier, up through slight, enhanced, moderate, and finally high, the highest and rarest tier, typically issued only a handful of times per year nationwide. This week's outlook reached moderate risk, the second highest tier, across parts of Oklahoma, Kansas, and Missouri, with SPC forecasters explicitly flagging the potential for what the agency's technical discussion called a significant tornado threat, including the possibility of strong, long-track tornadoes. That specific phrase, long track, is doing real meteorological work here, since a tornado on the ground for an extended distance is historically responsible for a disproportionate share of tornado fatalities compared to shorter-lived, weaker circulations. Here is what the Storm Prediction Center has not said, and this distinction matters enormously. SPC outlooks describe atmospheric conditions favorable for severe weather, categorized by risk tier and geographic area. They do not, and structurally cannot, forecast a specific death toll, nor can they rank an upcoming event against historical outbreaks before it has actually happened. The claim that the deadliest tornado outbreak in history is being forecast is not a statement that originates from SPC, NOAA, or any peer-reviewed forecasting methodology. Scientists generally do not conclude outbreak severity rankings in advance, because tornado outbreak lethality depends heavily on factors that cannot be forecast days ahead of time, including the exact overnight timing of tornado-warned storms, how many tornadoes track directly through populated areas versus open land, and how quickly warnings reach people in the storm's path. There is currently no scientific evidence, and no forecasting methodology capable of producing evidence, that ranks this week's setup against the deadliest outbreaks in U.S. history before the event has occurred. Let's talk about what actually makes this setup meteorologically significant, separate from the exaggerated framing circulating online. Forecasters identified 3 ingredients converging simultaneously: a strong, low-level jet stream transporting exceptionally moist, unstable air northward from the Gulf of Mexico, a potent upper-level disturbance providing the lift needed to trigger storm development across a wide area rather than isolated cells, and significant directional wind shear through the lower atmosphere, the ingredient most directly tied to whether a thunderstorm organizes into a rotating supercell capable of producing a tornado rather than dissipating as ordinary rain. To put that in context, all 3 ingredients are individually common during spring severe weather season. What is comparatively rare is all 3 reaching this magnitude across this wide, a geographic footprint at the same time, which is precisely why SPC's confidence reached the moderate risk tier rather than the more typical, slight or enhanced designations that cover the large majority of severe weather days nationwide. Now let's put this in historical context, because the record of past outbreaks is the actual benchmark researchers use, not a real-time ranking system. The deadliest tornado event in recorded U.S. history remains the tri-state tornado of March 18th, 1925, a single long-track tornado that traveled an unprecedented 219 miles across Missouri, Illinois, and Indiana, killing 695 people at a time when warning systems as we understand them today did not exist. The deadliest outbreak involving multiple tornadoes was the 2011 super outbreak, which produced 360 confirmed tornadoes across the Southeast and Midwest over a 4-day span in April of that year, killing 324 people, the deadliest outbreak since modern Doppler radar and the current watch and warning system were in place. That comparison matters because it shows that even with today's substantially improved warning infrastructure, the specific combination of long-track, high-intensity tornadoes tracking through populated areas at night remains capable of producing mass casualties, which is exactly the scenario this week's technical discussion is flagging as a genuine, elevated concern without needing exaggerated framing to justify the seriousness. Here is why nighttime timing specifically raises the stakes so much. Research published by NOAA's National Severe Storms Laboratory has found that nocturnal tornadoes are roughly twice as likely to be fatal as tornadoes occurring during daylight hours, driven primarily by reduced visibility, lower rates of people actively monitoring warnings while asleep, and the loss of visual confirmation that often prompts faster sheltering during daytime events. Current forecast timing for the most significant severe weather window this week falls disproportionately in the overnight and early morning hours across parts of Oklahoma and Kansas. A detail meteorologists have specifically highlighted in briefings to emergency management officials as the single factor most likely to elevate the human toll of this event, regardless of how the tornado count itself compares to historical outbreaks. Let's talk about the enhanced Fujita scale for a moment, because tornado intensity classification is another area where online claims frequently outrun the actual science. Tornadoes are rated EF0 through EF5 based on a post-event damage survey conducted by National Weather Service meteorologists examining structural damage, debris patterns, and vegetation impact, not by any real-time wind speed measurement during the storm itself. That means no forecaster, however confident in the setup, can responsibly claim in advance that this week's storms will produce EF4 or EF5 tornadoes, since that rating is only ever assigned after the fact, based on physical evidence left behind. What forecasters can and did say is that the wind, shear, and instability profile is consistent with an environment capable of supporting strong, long-track tornadoes, technical language that has been repeatedly stripped of its careful qualifiers as this story has spread online. Keep an eye on the enhanced risk expansion, too, because that is typically how meteorologists communicate genuine escalating confidence as an event approaches. SPC outlooks are updated multiple times daily as an event window nears, and any escalation from moderate to high risk, or a significant geographic expansion of the highest risk zone, would represent forecasters actually raising their confidence based on new model data, a far more meaningful signal than any online claim about historical rankings made before a single storm has formed. The difference between an outbreak that causes catastrophic loss of life and one that, despite significant tornado activity, results in comparatively few casualties is not luck. It is warning lead time, sheltering behavior, and how seriously communities in the outlook area take the threat in the hours beforehand. The National Weather Service's warning lead time for tornadoes has improved from an average of roughly 5 minutes in the 1980s to approximately 13 minutes today, driven by dual polarization radar technology and improved warning algorithms. Extra minutes that have measurably reduced fatality rates in comparable outbreaks over the past decade, even as population density in tornado. Alley communities has continued to grow. So what happens next? The Storm Prediction Center will continue issuing updated outlooks as the event window approaches, and local National Weather Service offices across the affected region will issue tornado watches and eventually tornado warnings as storms actually develop and rotation is confirmed on radar or by trained spotters. Despite dramatic online headlines claiming this outbreak has already been ranked against history, there is currently no scientific evidence or forecasting methodology supporting that specific claim, and the actual technical picture, a genuine moderate risk setup with a concerning overnight timing component, is serious enough on its own without needing exaggeration. Let's go deeper on why the deadliest in history framing spread as fast as it did, because understanding the mechanism helps you spot it the next time a severe weather story blows up online. Moderate risk outlooks generate real, substantial media coverage because they are genuinely uncommon. SPC issues fewer than a dozen moderate or high-risk days in a typical year nationwide. When a legitimate technical discussion using phrases like significant tornado threat and long-track tornadoes possible gets picked up by aggregator accounts without the surrounding qualifiers, the language compresses fast, possible becomes confirmed, and a comparison to historical outbreak counts in a forecaster's internal discussion becomes a direct ranking claim that no meteorologist actually made. This is the same pattern researchers in other fields have flagged repeatedly. Technical caution stripped down into a headline that reads as far more certain than the underlying science supports. It's also worth understanding what a particularly dangerous situation Tornado Watch actually signals, since that is the real escalation tier to watch for, not anything published in advance of the event. A standard Tornado Watch indicates conditions are favorable for tornado development across a defined area and time window. A PDS Tornado Watch, issued far less frequently, indicates forecasters have unusually high confidence in strong, potentially long-track tornadoes specifically, based on real-time atmospheric data as the event approaches, not a prediction made days ahead of time. If a PDS watch is issued for any part of this week's outlook area, that is the genuine, forecaster-confirmed signal of elevated danger, distinct from anything claimed about historical rankings before the fact. Now let's talk about the broader seasonal context, since this outbreak setup did not appear in isolation. This year's severe weather season has tracked an unusually active pattern across the plains and Midwest, consistent with a La Niña-influenced jet stream configuration that tends to favor more frequent southern and central plains severe weather setups compared to El Niño years. Multiple enhanced and moderate risk days have already occurred earlier this season, and this week's setup represents a continuation of that active pattern rather than an isolated, unprecedented anomaly, another detail that separates the genuine meteorological story from the historical ranking claim attached to it online. This is also a moment worth using as a genuine prompt rather than a scare. If you live anywhere in the outlook area for this event, or anywhere in Tornado Alley more broadly, this is a reasonable point to make sure you actually have a way to receive warnings while you sleep, whether that is a NOAA weather radio with a tone alert or a phone-based wireless emergency alert enabled, and that you know exactly where your safe shelter location is before the storms arrive rather than figuring it out in the moment. We'll continue tracking this story as new outlooks are issued, and if the Storm Prediction Center escalates this event to high risk, we will bring you the details as soon as they are confirmed, not before. Let us go. See you in the next one.